Hello and welcome back to our YouTube channel. So in this video we are going to see what we call implicit differentiation. And implicit differentiation, before we begin it, we need to know the types of functions which are first known as implicit functions before we see how to apply implicit differentiation on those functions. Well, I'll begin by saying about explicit. When we talk of functions y equals to f of x, we call it explicit functions. But functions like, let us say, y equals xy plus y squared plus 3. These are now functions that we call implicit functions. And to find the derivative of this type of functions, what you simply do is that you just simply let your y to be equals to f of x. Okay, so you replace y as f of x as a function of x in the equation, and after that you then now go ahead to find your derivatives of each term. Then at the end you then now factorize your f prime of x. In the example we'll see how to do that. Then at the end you find out your f prime of x, and from your f prime of x you make now the f prime of x the subject, and then you replace back your f prime of x with y prime. That is, we let y to be equals to f prime of x like this. Then if we differentiate this, y prime will be equals to f prime of x. Okay, so now this is what we are going to do. So let us just apply on this example that I just used. So if you apply it here, the implicit differentiation is saying that differentiate term by term after replacing your y to be equals to f of x. So we now have f of x to be equal to x f of x plus f of x, all that squared, plus 3. So we are now going to find the derivative of f of x, and the derivative will simply give you f prime of x, that is 1 multiplied by f prime of x. Each time you find the derivative of this, you attach the f prime of x. So the derivative of f of x is simply 1 multiplied by f prime of x, you attach it, plus this one, x and f of x is now two functions of x, not plus, equals, we now get x f of x. So this one are two different functions. We're gonna find the derivatives, so we keep one constant, we differentiate the rest, and then we do that. So we apply product rule. You can watch the video for product rule. So our u is simply x and our v is equals to f of x. So it is telling us that we are going to find uv functions in the form of u. The derivative is u prime v plus v prime u. And let us begin. U prime, the derivative of x is simply 1 multiplied by our v, which is f of x, plus v prime is the derivative of f of x, and the derivative of this will just give us 1 f prime of x. We just attach our f prime of x multiplied by u, and our u is what? X. Okay, plus now we find the derivative of this other term. The derivative of this one will now be plus the derivative of this will just bring 2 into f of x, that is, you bring down the 2, then you multiply by f of x to the 2 minus 1, you get 2 f of x, then multiply our f prime of x. Each time you differentiate f of x, always put your f prime of x, plus the derivative of 3 is a constant, you get 0. And with this you simply get 1 multiplied by f of prime of x, we just simply get f prime of x. That will be equals to 1 times f prime of x, we still get another f of x, we still get another f of x, plus f prime of x times f, we can write it as x f prime of x, plus this can give us 2 f of x plus f prime of x. And now what we are going to do from here is simply to group the like terms, that is the terms with f prime of x. So I'll take this f prime of x term on this other side, so we'll be having f prime of x should be equals to f of x plus f prime of x minus x f prime of x minus this other term f prime of x, and that will be equals to f of x plus 2 f of x. And you see here that this f of x minus this f of x cancels, and we just get negative x f prime of x to be equals to f of x plus 2 f of x. And from here I can divide both sides by negative x. should I get my f prime of x? My f prime of x will be indeed equals to f of x plus 2 f of x all on negative x. And recall that y equals f of x, so y prime will be equals to f prime of x. Okay, differentiate both sides. So we can now go ahead and see that this is now our y prime, and this is our y's. So if we apply that neatly, since we started with x and y's, let us also end with x's and y's. So we get our y prime to be equals to f of x, which is y, plus 2 f of x, which will be 2y, all that on negative x, and we get our dy on dx to be equals to 3y on negative x, or negative 3y on x. And this is how you applied implicit differentiation. You simply let your y to be f of x, and you take the derivative of each term. Okay, you take the derivative of each term, and the end, make sure each time you differentiate f of x, you attach your f prime of x. Please just give this video a like and subscribe to the YouTube channel. If you find the video very helpful, you can comment in the comment section below, let us know. And thanks you very much, and have a great day.